All right, let's look at the complex inverse trig functions. All right, so I'm gonna just dive into an example. All right, let's try to find the value of arc cosine of 2. All right, so let's set this guy equal to, since it's a complex number, so I'm gonna call this guy z. All right. Then since, so using the definition of inverse cosine, so this is going to be equal to, let's see, so let's rewrite it in terms of regular cosine. So it's cosine of z is equal to 2, right? Basically, we take the cosine of both sides, so we get that. All right. But the cosine, by definition, so let's write the definition. Cosine is e to the iz plus e to the negative iz over 2, which is equal to 2. Right? So I don't like fractions, so I'm going to just multiply both sides by 2. So you get e to the iz plus e to the negative iz is equal to 4. Right? Then I'm going to do a substitution here. I'm going to let u be e to the iz. Then you will get e to the iz is u plus e to the negative iz, so it's going to be u to the negative 1 is equal to 4. Alright, I don't like negative powers, so I'm going to multiply through by u to get u squared plus 1 is equal to 4u. Alright, then we can subtract the 4u so that everything is on the left hand side. So u squared minus 4u plus 1 is equal to 0. Right? Then we can use the quadratic formula to find u. Right? So by using the quadratic formula, we get, so I'm going to go up here. Right? U is going to be, right, so in this case, right, A is 1, B is negative 4, and C is 1, right? So we have negative B, so it's going to be 4, plus or minus square root of B squared, so it's 16, minus 4ac, so 4 times 1 times 1, so it's just going to be 4, and over 2a, so it's going to be 2 times 1. So we have that. All right, then what we get is, let's see, so we have 4 plus or minus, so square root of 12, that will be the same thing as 4 times 3, so it's 2 square root of 3 over 2. Then we can see that 4 divided by 2 is 2, and plus or minus 2 square root of 3 divided by 2 is square root of 3. Right? So we found the u value, but this is equal to, alright, so this means that the u, which is, what is u? U is e to the iz, alright, is equal to 2 plus or minus square root of 3, right? Then we can just take the natural log of both sides. So you have e to the natural log of e to the iz, you're going to get the iz, right? Then you have a natural log of 2 plus or minus square root of 3, right? And this guy is, right, so absolute value of a real number is the same real number, so it's a natural log of, as long as it's positive, looks like it is. So you have a 2 plus or minus square root of 3, right, plus I times the angle, right? So angle, in this case, since it's a positive real number, angle is going to be 0 plus any multiple of 2 pi. So we have that, right? So therefore, what we get is, well, actually before that, we have to isolate z, so we multiply by negative I, right? So negative I and I cancel out because it's going to give you 1. So you have z is equal to, which is exactly what we were looking for, right? Negative I natural log of 2 plus or minus square root of 3, right? Negative I times I gives you positive 2n pi. Alright, so therefore what you get is cosine, arc cosine I should say, of 2 is actually multi-valued. So 2n pi minus I natural log of 2 plus or minus square root of 3. Right? So that's that. Right? Alright, that's it. I hope that this was clear.